To explain the concept of equilibrium, let's say we have a beaker, and inside this beaker we put some water. Also, we make sure that this beaker has a lid on it. Some of the water molecules are going to evaporate, change from the liquid molecules into gaseous molecules. And eventually, once we have enough gaseous molecules here in the space above the water surface, some of the gaseous water is going to condense back and turn into liquid water. To represent these two processes, the evaporation and the condensation, we can show liquid water on the left. So this is the liquid water, and we will draw it with the same color. And the gaseous water, will imagine that these are the molecules on the right. So in the forward process, I can see that this is the forward going from the left to the right. Liquid water turns into gaseous water. And that's represented by the arrow at the top here. And this is the process of evaporation. This is the process of evaporation or vaporization. And when the gaseous water turns back into liquid water, that's represented by the arrow here on the bottom, that's the process of the condensation. Since when we start with the liquid water as the first, the beginning is the rate of vaporization is very high because there was no at the beginning any molecules of gas. So when we started at the beginning, we can delete this once to explain that there were no molecules of gaseous water. So the rate was very high for evaporation or vaporization, more than the rate of condensation, because there are no gas molecules to condense back. But eventually, when we reach the point that there is a lot of gaseous molecules, some of the gaseous molecules are going to condense back into the liquid molecules, and there will be a point where the rate of vaporization is equal to the rate of the condensation. So the rate of vaporization is equal to the rate of the condensation. And when this happens, if you are turning liquid water into gaseous water at the same rate, you are turning gaseous water back into the liquid water. The number of the water molecules, let's imagine that this is the water molecules surface. So this is the surface here, and I will show this surface here like that. So I will show it here like that, and this is the surface. So I have like 3 molecules of water in the gas and 3 molecules in the liquid. So the speed by which the water molecules are evaporating is equal to the speed by which the water molecules in the gaseous form are condensing back. So the number of water molecules in the liquid and the gaseous phase will remain constant. So when the rate of vaporization is equal to the rate of condensation, we reached a state of equilibrium. And we will call this state equilibrium as dynamic equilibrium. Why we will call this a dynamic equilibrium? Because when we look at this, the water molecules are being converted from the liquid state into the gaseous state all the time. So the process of changing the water molecules into gas molecules and gas molecules into water molecules does not stop any second. However, since the rates are equal, the number of molecules in the liquid and the number of molecules in the gas will remain constant. And if we look at it from a macroscopic point of view, like when I look at it, I feel that the level of water would not change. The amount of water will never change at all. Now let's apply this concept of dynamic equilibrium to a chemical reaction instead of a physical change and see how it will look like.